to welcome Mr. Prakash Narayanan and Mr. Arvind Parameshwaran onto the stage to introduce us to Vedic mathematics. Mr. Prakash Narayanan and Mr. Arvind Parameshwaran are IT professionals. They will speak about certain basic techniques in Vedic maths and enlighten us about the influences of these techniques on later day developments in the field of mathematics.
Die folgende Präsentation über die vedische Mathematik wird von Herrn Prakash Narayanan und Herrn Arvind Parameshwaran gehalten.
So, good evening, my dear friends. So it's time now to learn some mathematical techniques, some simple mathematics techniques. Basically, me and Arvind, we are working as software professionals in SAP in Waldorf. We are not mathematicians or mathematical teachers also. But still, we have some basic interest in this particular subject. So that's why we prepared some slides on this. So we will go through some of the findings and history about the mathematics section of the ancient Indians, basically, and then the medieval times to the modern times. Basically, we will concentrate on the Vedic times, the mathematical foundations. So, if I tell you the roadmap or the how it was founded and how it went on, the greatest invention that mankind has been found is clearly the number called Shunya. Zero was called later, but it was named as Shunya. And then the decimal system, and I will show you a graph later, but the order is like this. When Shunya was founded, the decimal system was founded, it never ended there. The ancient mathematicians went on and then founded the infinite series and calculus and everything related to all mathematical branches. Basically the trigonometry, algebra and everything was included in this. So the fundamental idea is actually, it's not about mathematics simply. The saints or the Vedic scholars, they were actually very they knew these mathematical techniques very by heart, and they knew it very thoroughly. And all the calculation, all the constructions, everything was based on these particular mathematics. That was the understanding, that was the findings. So if you see some amazing temple architecture, you can see that how sun appears in the corridor of the temple. When the rain comes, how much water can be occupied inside. And if you see some of the Kerala temple architecture, the particular calculations have been made, how the roof can be made, roof is situated and everything. So all this architecture, all these findings were based on the mathematical wonder by which the saints were calculating. So after this architecture, it was nearly for thousands of centuries it was going on. The roadmap was actually, this was taken by the Arabs and then was promoted to Europe. So I will just show this particular one. So if you go through this screen, Aryabhatta was living in the year called 476 AD, and then came the Brahmagupta. Aryabhatta and Brahmagupta was nearly contemporaries. Then came Madhava and Nilakanta. Madhava and Nilakanta very recently, the NASA has described that the Kerala School of Mathematics, both were Malayalis, and Madhava and Nilakanta was called as the father of calculus now. So that I will describe now. And Madhava and Nilakanta, the same thing was actually invented by Newton and Leibniz and later by Euler. Whether Newton and Leibniz knew about Madhava's invention or something, we don't know. But the thing is now found, the Kerala School of Mathematics, which Madhava and Nilakanta founded, is now out, and then it has been correctly found that all the current mathematical findings is absolutely correct according to Madhava's this one. So So where will we start, and how the Vedic mathematics is important, and how it was? How can I say that this was there sometimes? The first Brahmi numerals in the world was found in Pune. That is now crystal clear. In the Pune, it was found that these Brahmi numerals have been found. So initially, during the pre-Vedic eras, as you can see on the left side, they used yardsticks to count. So the yardsticks were counted. So you can see that 1, 2, 3 is the yardsticks. But when you twist the yardsticks slightly, you see the numbers are counted. And then, as you can see on the right hand side, the top row is the modern numbers, and the bottom row is the Brahmi numerals. So you can see that how it is arranged there. So this was arranged when 1 division, 2 division, 3 division, 4 division, and everything. So they had, in fact, all the numerals for the first 10 characters. So after this, so we will go to the biggest invention what India has given to the world from the Vedic era. So this is given by the saint. He was a sage, Brahmagupta. Brahmagupta wrote the book called Brahmaspuda Siddhanta. So as there is some calculations actually, like how much Vedic era was there, how long a man will live, how long a Brahma will live, and everything. So as they say that Brahma's one day is 1,000 years of one human, this one and everything. So there is a complex calculation, and Brahmagupta was very interested to calculate all these things. So in order to do that particular research, he has written the book called Brahmaspuda Siddhanta, out of which the early finding of zero can be founded. So the one basic thing is actually zero. The importance is actually the number, how it represents. So as you know that we Indians, we believe in reincarnation. A reincarnation means the life is not a linear thing. Life is not started here in this birth or it is ending in this birth. It is a continuous process. So this is clearly defined actually in the Ishavasya Upanishad, where they say Om Purnamada Purnamidam Purnamudachyate Purnasya Purnamadaya Purnameva Sheshate. It means the wholeness is derived from wholeness. When you remove wholeness, the wholeness remains. It's the same thing on the other part. When there is void, when there is emptiness, when you remove emptiness, emptiness still remains. So that is the idea of zero actually, where the shunya had come. That's a philosophical idea, how they invented it and how the number was given that particular picture. So Brahmagupta clearly defined first time how the zero was found. The initial idea is actually like when you subtract one number from the same number, there was no answer. What will be that? What is the result? So Brahmagupta has defined that, okay, when you subtract one number, the same number, zero is the answer. And then in this Brahmaspuda Siddhanta, he defined clearly what is a property, what is a depth, which is clearly what is a positive number, and what is a negative number. So after that, I can say that Aryabhatta came. Aryabhatta's invention was a little bit earlier, where he didn't define zero. But Aryabhatta is the inventor of the 10-digit system, basically. So he clearly defined in the book that sthana sthanam dashagunam syayat. So means from place to place, each is 10 times the preceding. Then comes 1, 2, 3 to 9, and then the number of 0. So Aryabhatta basically had clearly given the numerical values to 33 consonants. And the 33 consonants have been calculated to the 10 to the power of 8 correctly. Till now, the value is absolutely correct. That's our understanding. And the great invention by Aryabhatta was the approximation of pi. Actually, Aryabhatta was only able to give some approximation of pi. Pi was calculated only for 5 digits. So I think you know what is meant by pi. Pi is the circumference divided by the diameter of a circle, and this is one of the very basic of mathematics. But Aryabhatta in 498 AD was calculating this number to 5 digits very correctly actually. And in India, actually, Aryabhata's contributions, not only in mathematics, in astronomy is tremendous, and it is influenced a lot. So I can say that India's first satellite we named after Aryabhata, and it was called Aryabhata. So maybe I will hand over to Aravind now. So he will show you some of the mathematical calculations, how it can be very easy and funny. So which is called a Nikhilam Sutra.
Yeah, to start with, there are around 16 sutras, but we will not be able to cover everything in a short time frame, but so we are just covering two very interesting sutras. So these sutras, whatever we have, these were all written in palm leaves or things like that. So, or by mouth of it. So the first one, the Nikhilam Sutra, the first example. So you are multiplying 82 by 88. So these are the digits, or these are the numbers where the end digit adds to 10. So you can see 82 and 88, the last two digits is 2 and 8. When you add, it is 10. So this technique can be used only in such cases. So as I said, there are 16 different sutras, different techniques for subtraction, addition, division, everything. But right now we concentrate only on two. So it's very simple. So if the end digits are adding to 10, just multiply those two digits. 2 into 8, 16, write it down. And the other two, you add, for the first, you add 1 to the first, since here it is 8, so 8 plus 1, then that is 9, and multiply with the second digit. So 9 into 8 is 72. Join together 7216. So simple. Similar thing, another example, same scenario, 65 you multiply by 65. So the last two digits adds to 10, 5 into 5, 25, and the next two digits add add plus 1 to the first digit and multiply the second. 6 plus 1 into 6, so that is 7 into 6 is 42, add to 44, 4225. And when you come to the normal digit, the small one, 8 into 7. So here, as Prakash said, we take the decimal like tens. So you see the difference from the 10. So the first digit 8, from 10 it is 2. So that is 8 minus 2. And then from 7 to 10 it is 3. So you write 8 minus 2 and 7 minus 3, and you multiply the two digits, 2 into 3, 6. And when you subtract this thing, diagonally you have to subtract. So 7 minus 2 and 8 minus 3. So all the time it will be the same. So 8 minus 3 or 7 minus 2, it is 5. So the multiplication is 56. So the same scenario, we again using to multiply by 92 to 98. So here, not 10, we take the difference from 100. So that is 92, to 100 it is 8, and from 98 it is 2. You multiply 8 and 2, 16, and then subtract diagonally, so it is 90. So it's another scenario, 87 into 86. So here again the difference from 100 is a bit higher, so it's 13 and 14. So 87 it is 13, and 86 it is 14. So you multiply 13 and 14, it is 182. And the difference, that is always 73. But the 182 you cannot add it to this one, because the number cannot be 73, 182 when you multiply by 87. So the trick is, you take the 1 and add it to the 73, the next, so it is 74. So it is 74, 82. Carry forward like that. So it is the Nikhilam Sutra. So a little bit complicated. So the next sutra, Paravatryojayat. So here it is x cube plus 7x square. So it is a little bit more complex. So here we are dividing x cube plus 7x square plus 6x plus 5 divided by x minus 2. So okay, the first is x cube, and here in the bottom we have x minus 2. So you divide x cube by, whenever it is x cube and bottom it is x, always the first digit will be x square. So in the answer you divide x cube divided by x, so you have x square. Then from the minus 2 you multiply to the answer. So okay, the first digit is x square. Now you are coming to the next one. So the minus 2 you multiply to x square, so you have minus 2x square. Then you see the distance between 7x square and the minus 2x square. So that is a 9x square. And that 9x square you divide by x. So you have the second thing, its second number, it is 9x. And then you multiply minus 2 to 9x, which is minus 18x. And the difference from 6x and minus 18x, so that is 24x. And 24x you divide by, again by x, so you have 24. And then this 24 you multiply by minus 2, which is minus 48. And the difference between minus 48 and 5 is 53, which is the remainder. So these are some small or very simple techniques we have of the 2 sutras, but you have 16 different sutras, which is so simple techniques for multiplication, division, and all such things. So if we would have known this maybe at when we were studying, maybe we would have scored a little bit more high scores. Yeah. Yeah, and when you take the history of mathematics, Kerala School of Astronomy and Mathematics, so they have a very, very prominent part to play in the mathematics of India. So the Madhava series, so whatever this Kerala School of Mathematics was started by Madhava of Sangagrama. So whatever he invented, it was all never clearly written down. So everything, whatever is available in Kerala School of Mathematics, it has been like as told by Madhava and things like that. But he had, in Madhava's words, he already had proved the sine series. Madhava sine series is there, cosine series is there, but which was defined or which now known as okay by Isaac Newton and Leibniz and all later in the 17th century and all. Also another important person from the Kerala School of Mathematics or scientist is Jeshtadeva. So he had the initial or the calculus, early text on calculus, he already had it. That was in somewhere in 14th century. And also Madhava had the value of pi. And now it is known as in Madhava's name, Madhava Leibniz series and all. So the current scientists, they have already approved that okay, Madhava or our own old scientists, they had proved it, or they had the only problem I think I would say they didn't have is they don't have a clear written format. They have everything was written on leaves and all, just lost by the time. But whatever they have from that right now, it has been defined, or they have already. The scientists, they have. I don't get the word. Yeah. Okay. Let's go to the next one. So before concluding, we would like to tell the mathematical legends, Indian mathematical legends, to start with Aryabhatta, Susruta, Brahmagupta, Madhava, Bhaskara, Parameshwara, Nilakanta Somyaji, Jeshtadeva, Achyuta Pisharadi, Elpatur Narayana Bhattadri, and Achyuta Manikar. So they have they had done very much contribution to the mathematics. Before we end, when we talk about mathematics in India, we cannot omit Srinivasa Ramanujan, who was simply genius. So he also had, I mean, he was born in somewhere in 19th. I think he died at very young age. He was only 32-year-old. So when he died, he was a simple clerk in Chennai. And whatever he had, he proved a lot of theorems, almost 3,900 results, out of which he just written on his some small workbook and all. And this was very unconventional. And almost out of this 3,900 results, many are proved to be correct, but there are still some which were false. But okay, at that time you can imagine how he had. But and the Ramanujan number 1729, and this is the particular or the importance of this number. This is the smallest possible number which can be expressed as the cube of sum of cubes of two different numbers. For example, 10 and 9 and 12 and 1. So there is no, this is the smallest number which can be expressed. And how it came out is like his mentor in UK, in England, Hardy, he just came and told, okay, yeah, this is, I came in a taxi and this, my taxi number was 1729. I felt, okay, this number. He said, no, it's not just an odd number. This is the, and he was on hospital bed. And on hospital bed, he was telling that, okay, this is the number. So there are a lot of theorems which by Ramanujan, which is proved now and which has given important contribution to the mathematics. Yeah. We hope we are able to give you a little bit insight into the mathematics which was there in the Vedic era. So I think we have to, even we have to go through a lot of things, because a lot of sutras, 16 sutras, so maybe for our younger generation, when they find it difficult to multiply, difficult to divide, yes, there is some easy techniques available which we can tell, which is easy to understand also. Thank you.